Sorry. I'm here. Oh my god. I've been up for an hour. And for the last half an hour, I finally think I got this computer started. I hope working. Oh my gosh. This has been a tough morning. It's 5:56. Oh my gosh. Alright, so this will be the warm-up that we do in class. I think you guys can handle it, so I'm not going to do it in this video. All you got to do is find the missing sides and missing angles by using some old horse caught another horse taking oats away. So you can do that. We'll do that as a warm-up in class. That's not a bad problem. But what happens if the triangle's not right? If the triangle's not a right triangle, what are we going to do? What's our options, Let's say we have the triangle A, B, and C, little a, little b, and little c. What are we going to do? Well, believe it or not, this is review for you because we are going to use something you learned last year called the Law of Sine. So I will assume that you have at least heard this before. You did problems with it last year, and we will go through it rather quickly, okay? But the law of sines, remember, and depends on how it looks on your formula sheet, but I believe it on your formula sheet it looks like this. A over sine A equals B over sine B equals C over sine C. Now, I'm not really sure if that's how it looks. It's on here. Let me do this. If I can copy this. Copy it. Paste. Yes. Since we're going to need this a lot, let's take this and move it up here. Okay. So there's our formula sheet. Our formula sheet, there's the law of sines right here. So, yep, that's how they write it. So that's how we're going to do it. It doesn't matter if you put the angles on top and the sides on the bottom. It really makes no difference. It's just a ratio, or excuse me, it's just a proportion. Two ratios equal each other. It doesn't matter how you set that up. So we're going to find the side length. Find the length of the indicated side to the nearest integer. So we'll round to the nearest integer. So what do we have? We have an angle Q and the side opposite it. Angle Q. So 54 over the sine of 18 degrees is equal to r, little r, over the sine of 73 degrees. Now, it's a proportion, so you'll have two fractions equal each other. Therefore, you have to have just one missing thing. If you have more than one missing thing, you're probably doing something wrong. My glasses are dirty. I got to clean them. But we should only have like one thing we have to find. If you have two things, then you got to go do something. You got to do something else because it's not going to work. So we'll just cross multiply. So we get 54 times the sine of 73 equals r times the sine of 18. Don't use your calculator until you have completely solved for r. Sine of 18. Sine of 18. And these cancel. And so now I'm ready to put this whole thing into my calculator. So 54, oops. Sine of 73. Of course, we forgot the 5. We're having real kinds of problems today. 54 sine 73 all over sine of 18. Hope I got that right. And we get 167.112, so we get r equals 167.112028. Good enough. R equals 167. We're going to find little f. So we're going to do f over the sine of 45 is equal to 127 over the sine of e. So we got a little problem here. I don't know e, and I don't know f. But I have to use f and f And I have to use this 127, and I have to use E, but I don't know E. So your first job is to actually figure out what E is. So that's pretty easy. I mean, that should be pretty obvious what you have to do here, I hope. These two add up to 110. So if those add up to 110, then this must be 70. So I can come over here and say, okay, I actually do know E. It's 70. And now I can cross multiply. 127 times the sine of 45 is equal to F times the sine of 70. Divide by sine of 70. Divide by sine of 70. Now I'm ready for my calculator. Go to my calculator, and I do control division. What do we've got? We've got 127. I got it right there. 127 sine of 45 equals, oh no, all over sine of 70. Enter. 95, 56588. 95, 56, 588. I think it was 588. All right. So the answer is, round to the nearest integer, F equals 96. All right. Oh, what am I doing? I was just about to use my finger to flip the page on the computer. Wow. I think I need some more coffee. We haven't taken time to have a Brugger's commercial yet, so this is a Brugger's commercial. All right, that commercial's over because they're not paying me. Actually, they're not paying anybody. They're going bankrupt. Poor Brugger's. All right, so here, what am I doing? Am I doing these? 1, 2, 3, 4. All right, these you got to do yourself, but I'm just going to remind you. I'll help you out with this labeling here. Oh, I was going to do 7. Am I doing 7? Wait a second. What happened? I don't even have a 5 on mine. Oh, my numbering is all off. Son of a... Alright. So I am doing... Actually, I am going to do these two. I thought I was doing these two. I just have a different numbering system on my thing because... I don't know why. So there's A, B, C. Across from little a goes 20. Across from capital A goes 20. Across from capital B goes 11. And... oh, man. I forgot what kind of problem we're working on. All right, so, whew, glad I found it because I would have run out of room. Let me do this a little bit smaller. Let me blow up. Maybe blow it up a little bit so you can see it a little bit better. All right, so this is better. So the question says this, actually. How many different triangles are possible? Solve the triangles and round answers to the nearest tenth. So whatever answers I got to come up with, I got to round them to the nearest tenth. But the first question is, how many triangles are possible? What? What do you mean, how many triangles are possible? Okay, there's a triangle. And I've got triangle A and B and C. And little a is 20. And little b is 11. And A is 115 degrees. So let me just explain this to you a little bit right over here real quick. And I'll try to do this in class as well. The way it works is because sine could be positive in the first quadrant. Let's say we have a 30-degree angle in the first quadrant. I know that the sine of 30 degrees is 1/2. If I come to the second quadrant, same reference angle, but really what I'm talking about is angle 150. So the sine of 150 is also 1/2. And because sine could be positive in the first or second quadrant, and when I'm working with triangles, all I have to do is have the triangles add up to 180 degrees. I theoretically can have, when I find an angle, I could say, oh, the sine of theta equals, let's say I end up with the sine of theta equals 0.215. Well, that could be this one that's in the first quadrant, or this one in the second quadrant? Don't think that really did what I'm about to do justice. So let's see if I can make it make more sense when I'm working with a triangle. I think I can. I'm like that train, that Thomas train. I think I can. All right. If I can't, we're in trouble. So I think I can. So let's do this. We're gonna use the law of sines first. We're first gonna use the law of sines. You'll see how this works. 20 over the sine of 115 equals 11 over sine of b. So our goal is to find b. All right. Cross multiply. I get 11 times the sine of 115 equals 20 times the sine of b. Weird. Okay, now I got to get b by a sine of b. So I got to get rid of the 20 actually. I'm going to get rid of that 20. I'll do my work over here now. Sine of b is equal to this. So this I'm going to put in my calculator. Control division 11 times the sine of 115 all over 20. Now, I don't really want to lose any of these because if I lose any of these, I'm rounding. So 0.4984, 0.4984. Usually 6 will be good enough. 692. Well, that's 7. Good enough. Okay. So now I want to figure out what b is equal to. Well, if I want to figure out what b is equal to, you have to remember that we have to bring the sine over to the other side and do inverse sine. So we're going to do b is equal to sine -1 of this really long decimal, 0.49844692. So what is b equal to? So I'm going to do inverse sine of that. And I get 28.898. So 28.898. 780. They told us to round to the tens place. So b is equal to 28.9. So now I have b. Wait a second. 49. Wait a second though. Now here's what I was talking about. That 0.489, that's like a half. That's almost a half. Isn't that close to 30 degrees? That 0.489, that's this angle. Well, what about in the other quadrant? Remember, it can either be 28.9 or it can be b can equal 180 minus 28.9, which is 150.1021. 150 point, we'll just round to the tens place, 1. So b can either be this angle in the second quadrant or this angle in the first quadrant, because b is positive in the first and second quadrant. It can be either one of those. So now we're going to try our triangles. Triangles. Here's what we got. We were given that angle 1 or angle A was 115. So we're checking to see how many triangles we can have. The answer is either 0, 1, or 2. Can't be 3. Angle A is 115. Angle B, we came up with 28.9, or angle B came up with 150.1. Now, the only way to find angle C is to do 180 minus these two. So let me do that. 180 minus 115 minus 28.9. 28.9 equals 36.1. 36.1. So there's 3 angles that add up to 180. Check. Angle C over here would be 180 minus, wait, these add up to more than 180. So I don't have anything left for a third angle. So we can't make two triangles. So that's done. The answer is one triangle, and there they are. All right. Let's see if I can do it justice again. Let's try it again. Told you I had a lot of work to do. Triangle ABC again. A, B, C. A is 40. B is 16. And A is 13. So we're going to do 13. So 13 over sine 40 is equal to 16 over sine of B. Same math then, right? 13 times the sine of B is equal to 16 times the sine of 40. Divide by 13. Divide by 13. And you get sine of B equals whatever that is. So we got to do that. 16 sine 40 over 13. 0.7911232. 0.7911232. Again, in order to find B, we move that over there, make it sine inverse. Sine negative 1 of 0.7911232. And we'll find that B is equal to 52.2906. So 52.2906. But that's the angle in quadrant 1. B can also be, or B can be 180 minus this. 180 minus this answer. Or B could be 127.709. Or B can be equal to 127.70939. 70939. Now, I know you don't believe me, so here's what I'm going to do. Well, maybe you do. Maybe you're smart enough to believe me because you know I'm smart. I wouldn't lie to you, but check this out. Let's do the sine of this first angle we came up with, 52.2. Now, it should come as no surprise that you get this 0.79113. Now we're going to do the sine of the second angle that we just came up with, the 127. And it should hopefully come as no surprise that you get the exact same decimal. That's because sine is positive in the first and second quadrant. So sine can equal this when it's 52 degrees or when it's 127 degrees. So now we have to decide, can we make two triangles or only one triangle? So here's our test. Angle A was given 40. This is triangle 1. This will be triangle 2. Angle A, 40 degrees. Angle B. We just found out that angle B can be either 52 degrees, 52.3, or angle B can equal 127.7. Now, to find angle C, we take 180 minus A minus B. So 180 minus 92.3. 180 minus 92.3, and our third angle would be 87.8. So angle C would be 87.7. Or over here, we take 180 minus 40 minus 127.7, and we get, 12. 12.3. So since I can come up with three angles that make 180 here and three angles that make 180 here that meet all these requirements that were given, the answer is two triangles can be formed. Remember, the answer is either going to be 0, 1, or 2. So you will have to do 9 and 10. Next problem I'm doing is oh wait, no wait. So you're gonna do, excuse me, 6 and 8. Next problem I'm doing is this one on the bottom, which should be 9. Okay, I'm gonna have to redo my numbering. I don't know what I did here. Okay. Okay, let's see what we got. Whoa. Let's back up to Crazy Train. By the way, I do more of these how many triangle questions later on. So if you're struggling, I'm going to keep going and do more triangle, those things, and you can come back to it, see if you can come back to it. So let me blow this up a little bit so you can see it a little bit better. All right, so we're looking for QR. Our goal is to figure out what QR is eventually. So let's see what we do have. We do have that PS is 82. We have that angle S is 38. Doesn't look anything like a 38-degree angle, does it? Remember, your drawings don't have to match. Angle 4 is 63 degrees. Clearly not a 63-degree angle. Angle 1 is a 46-degree angle. Angle Q is a 79-degree angle. And so the question is, what is QR? So don't write this down, but if I was doing this, QR, this is QR, we'll call this X. X is opposite angle 1. So I would have to put X over sine of 46, which would be equal to, let's see, well, either this side, let's call this Y, Y over angle 3. I can do angle 3. That's the sine of, let's see what if I can figure out what angle 3 is. Let me do the givens in different color, or the non-givens. 79 and 46. That's a 5, 11, 12, 125. So that would make this 55 degrees. So that would be the sine of 55. But you see my problem. I have 2 missing pieces. I'm not allowed to have 2 missing pieces. So I really can't do that. So maybe I don't even need to call that Y. We'll call that, we'll call this W right here. I don't know why. So then I would have to do W over the sine of Q, which is, I should probably call this Q then, right? Q over the sine of Q, and the sine of Q is 79. But again, I have the same exact problem. I'm missing 2 pieces. And you're not allowed to be missing 2 pieces when you're doing the law of sines. So the trick is, and the way you do these problems, not really a trick, but the way you do these problems is you have to find the piece that they share. Now I'm going to call it Q because it's opposite Q, but it's also opposite S. So I'm going to find the piece. Woo, almost dropped my coffee, kids. That would have been ugly. I want to find Q. So if you can find the piece that they share, then you can do the problem. So this is kind of like doing 2 problems at once right here. So Q is opposite S. So we're going to do sine of 38 is equal to, now this 82 here is opposite angle 4. So 82 over the sine of 63. And that's the only thing, based on the directions and the numbers that I've been given, that's the only thing I can do right now. So we're going to do this 82 times the sine of 38 is equal to Q times the sine of 63. Divide by sine 63. And I get Q, the in-between side. So let's go to calculator. 82 sine 38. 82 times the sine of 38 all over the sine of 63. Now, 56.65 9788, 9788, 2352. Now, Q is not my answer. And since Q is not my answer, you better not round yet. You can't round until the very end of the problem. But I do now know Q. It should be little q. I don't know why I use big Q. So now I can set up part 2 of the problem, which I'll do in my green pen. I'm going to do Q, little q, which is 56.65978825352, all over the sine of Q, which is 79, is going to equal the thing I'm looking for over, I'm looking for x, over the sine of, what's opposite x? It's down here. It's this angle right here, 46 degrees. All right, now I'm ready. X times the sine of 79 is equal to 56.65978825352 times the sine of 46. This probably might be behind my head, so all right, times sine of 46. And yeah, you're going to write all that out as much as possible. All right, and then I'm going to divide by sine of 79. And then we round at the end. Only then can I round. So I get x equals that mess. So let's go back to my calculator, control division. And it's this times the sine of, I think it was 79, 46, all over the sine of, this one 79, 79. And I get 41.52, 41.52048, 048. Probably enough. It says round to. It doesn't say round. All right, and 6 decimals it is. If it doesn't say round, 6 decimals it is. Let's say, for all intents and purposes for this paper, let's say we round to the hundredths place. If it doesn't say. If it doesn't say, we round to the hundredths place. So 52. Okay, there it is, 41.52. Let's keep going, because this is fun. So I am doing, what was that? What number was that? That would have been 11 on my list. Next one I'm doing this. I'm doing the, so you're going to handle that problem. It's basically the same problem. Basically the same problem. You're going to find the in-between side. You're going to find the side in the middle and use it to do the other one. I'm going to do this one. So hopefully you have the sheet in front of you. So from a point A on the ground of elevation to the top of the building is 66 degrees. From point B to the point A, the base is 43 meters apart. The angle of elevation from B to P is 39 degrees. Find the height of the building to the nearest meter. So I need to find this. Let me get a cool color in here. I need to find this called height. So if I wanted to, I could say, okay, this is a 90-degree angle. I can say, what can I do? I only have one thing in that triangle. And remember, if you're going to use some old hippie, you're going to use some old hippie caught another hippie tripping on alligators. You have to have 2, and I don't have 2. I only have 1. So just like the last problem, we have to find the side that they share, and the side that they share is right here. We're going to find this value, x, and x is really opposite that angle. So x over the sine of 39 is equal to, well, the only other thing I have is 43 over the sine of that thing, which I don't really know. So what am I going to do? There's got to be a way to do this. There just has to be. There just has to be, Mr. Grouse. I know there has to be. Is there a way to find this angle right here? I need this angle. I have to have this angle. And hopefully all of you are screaming at me right now. This is 39 degrees. and this is 60 degrees. So I should 66. So I should be able to find this one because that's 180 minus 66. So 180 minus 66 is 114 degrees. Now if I take that 114 degrees and I add 39, 114 plus 40 would be 154, so this is 153, and that makes this then 27 degrees, because they have to add up to 180. Now, the other way to do it, for those of you that are really smart from algebra, or from geometry, you know that the two remote angles have to add up to 66. So I could just take 66, subtract 39, and I would get 27 degrees. So 27 degrees it is, sine of 27. So now I'm ready to rock and roll. X times sine 27 is equal to 43 times the sine of 39. Divide by sine 27. And I get x equals, let's see, control division, sine of, oops, forgot the 43. 43 sine of 39 over sine of 27. 59.606. 59.606. 4825. 4825. Now, this is not my answer. It said find the height of the building. A lot of kids will find the height of the building to the nearest meter, and all of a sudden they're going to go, okay, that's 60. No. You cannot round until the very end. Sometimes you get lucky and it works. Most of the time you don't, because we math teachers like to mess with you for kids that don't pay attention. So now we know that x is 59 point something. So now I can go back and I can do, okay, I can do the law of sines again if I want to. 59.6064825 over the sine of 90 is equal to h over the sine of 66. Is equal to h over the sine of 66. Why is this pen so huge? I like purple, but let's get a small purple. Yeah, now we got small purple. So now it's h times the sine of 90 is equal to 59.6064825 times the sine of 66. All divided by the sine of 90. But isn't the sine of 90 just 1? Sine of 90 is just 1. I don't really need this. So I'm ready to rock and roll. Let's go. 59 divide times the sine of 66. So this thing times the sine of 66. And the height of my building is 5445. So 8.453. So my answer is h equals 54 meters to the nearest meter. Yay, we're done. All right. Done with that one. 12 is a bonus. 12 is a bonus. So we're moving on. What's the next problem I want to do? I wanted to do 13. Why am I doing that? Oh, no, I don't want to do 13. I want to do, I just did 13, 17. And 17 on your sheet is, because I'll leave that one. That one's not too bad. I think it's 15. All right, we're going to do this one right here. So it says A is 24, B is 25, angle A, this should say angle A, sorry. Angle A is 65. What types of triangles can be drawn? So acute means all the angles are less than 90 degrees. Obtuse means one angle greater than 90 degrees. Acute means one acute and one obtuse, and maybe neither. Maybe neither. So let's see what we got. Got a triangle. Call it B, C. Little a is 24, little b is 25, and this is 65. So we're going to use the law of sines. So 24 over the sine of 65 is equal to 25 over the sine of b. So I get 25 times the sine of 65 equals 24 times the sine of b. Divide by 24. Now to find sine, we're going to take this, bring sine inverse over here. So what I really end up with is then sine -1 of this huge mass is equal to b. So let's do that. Sine inverse. Well, let's just figure out what that division is. 25 sine 65. 25 sine 65 all over 24. Enter. And then we're going to take inverse of that. So sine inverse of that thing. And we get 70.746. So, son of a... Coffee's cold, and I spilled it all over myself. So what did we say B was? Go away. B is 70.746. So B equals 70.7. That's good enough, actually. Because really that's all we need to figure out if we can make a few triangles. So, oh wait. Or my other one is 180. B can equal 180 minus this. And 180 minus 70 is 110. So 109.3. These are my two possibilities for B. So now I say, okay, all right, so my triangle 1, it would be 65, 70.7, that's 135, so let's just do this, 180 minus 65 minus 70.7, I would have 44.3. 44.3. So this would be an acute triangle. So yes, we already got an acute. So I know it's not neither. So triangle 2 would be 65, 109.3. So now I'm going to take 180 and subtract those. I think I can make an angle out of these. 180 minus 109.3 minus 65 equals 5.7 degrees. So we can actually make two triangles from this. So the answer is both an acute and obtuse triangle. As long as I did something. For some reason I thought, no. I don't know. Anyway, that's the answers, kids. Woo! 17. The next problem I'm doing is 20, which is really 18. I gotta get this. Is it really 18? I don't understand. Let me get this unblown up a little bit. Oh my gosh. Oh, I know why I want to do this one, but why is this so messed up with my I'll have to fix that. All right. So the reason I want to do this is because you got these degrees and seconds and stuff. So we got to figure out what we got to do here. Find the measure of angle S to the nearest minute. So I would do little s over 8 over sine of S is equal to 17 over the sine of 90. Well, sine of 90 is just 1. So that's easy. So that's 8 equals 17 times the sine of S divide by 17, divide by 17, and I get sine of s is equal to 8 over 17. And some of you are thinking to yourself, well, isn't the sine of s equal to opposite over hypotenuse? Yep, there it is right there. Another way of doing it, kids. Law of sine is the same as what we were doing before. So I'm just going to go to my calculator. We'll do inverse sine of 8 divided by 17. 8 divided by 17. Enter, and then we'll DMS it. And it's 28.4, 28 degrees, 4 minutes, 20 seconds. Done. All right, the next problem I'm doing is, 21. All right, 21 is really 19. So we'll draw a quick little triangle. You guys love my rings. Little d is 5. Little e is 8. Isn't there a little e like a rapper? Little e. I'm like little e. And this is 32. So we're going to do 5 over the sine of 32 is equal to 8 over the sine of f. 8 times the sine of 32, cross multiplying, is equal to 5 times the sine of f. Divide by 5, divide by 5. These cancel. So what I end up with is the sine of f equals 8 times the sine of 32 all over 5. I can bring this sine inverse over and go f equals, and just do sine inverse of that whole mess. I'm just going to do that. I think it'll be faster. So sine inverse of this fraction, which is 8 times the sine of 32 all over 5. 57.98. So this is equal to 57.98. Now I don't care about rounding, so I'm really going to say this is 58 degrees, only because this is how many drawings can, or how many diagrams can be. So f can be 58, or it can be 180 minus 58. 180 minus 58 is 122. So triangle 1, possibility. 32 degrees, 58 degrees. Let's see, those add up to 90, don't they? So that would be my last angle, would be 90 degrees. Those add up to 180. All right, so ka-ching, that works. It's actually a right triangle. Not quite a right triangle because this isn't quite 58, but it's close. Triangle 2. Let's see if I can make 2 triangles. So instead of 32, we start with 32. I get 122. That's for 154. 154, that would leave plenty of over. That would give me 26. So I can make 2 triangles. The answer is 2 triangles can be made. Next problem I do is 21. What is it, 21? 22, 23. Oh, this one's a little tricky. It's actually 21, I think, for you guys. All right, so this one's a little bit tricky. Question says, 2 distinct triangles can be constructed if the measure of angle M is. So they're like, okay, we got this triangle M, N, P, and all we know is N is 6, and no, M is 6, N is 10. So that's all we know. And we're looking for angle M so that we can get 2 triangles. Well, the trick is you either got to probably pick the 35 or the 50. 35 or the 50. So let's see. Let's guess the 50. So we'll do 6 over the sine of 50 is equal to 10 over the sine of n. Now we're just assuming, we're making an assumption that this is 50. We're just saying, okay, we're going to use our answers. We're going to use 50. We're saying, that's our answer. We got it. So 10 sine 50 is equal to 6 times the sine of n. Divide by 6. And then what I have here is, let me just do that calculation. 10 sine 50 all over 6. And then, what? Well, we got to do the inverse sine of that, and you're going to see that's a problem. Inverse sine of this. Remember, sine can't be bigger than 1, so there's no way to inverse sine that, so 50 can't be the answer. So that's just not going to work. I can try this same thing with 45. So let's assume I picked 45. You're going to see probably this isn't going to work either. It's bigger. And try 40. So if you actually pick the other ones, by the time you got to this point right here, all heck would break loose. 40. And that's bigger than 1 again, too. So now we got to try 35. So we're just trying 35 now, seeing if that works. And I told you before, that one's bigger, that's less than 1. So we know this is the right answer, but let's see if we can figure out how to get 2 triangles out of that. So instead of using 50, we're now going to use 35. So now I've got sine of A is equal to 0.9. What the heck was that number? 0.95599559. Let's just figure out what A is. A is equal to the inverse sine of this. So inverse sine of this thing is equal to 72.9327. And again, it doesn't really matter. 72.9. This is about 73 degrees. So I go 35 and 73. There's plenty left over for that, right? What's the other angle? If it's 73, A could also be 107, right? So I can do 107 plus 35. There's still a lot left over for a third one, and that's where I get 2 triangles out of that. All right, that's kind of a weird question. 27. Okay, I'm going to do one more of these for you. I'm going to blow it up so you can see it. We want to find RS. So here's our goal, is to find X. I'm going to put all the givens in my fancy new purple pen. So I know that Q is 74. I know that angle 3 is 41. I know that angle 2 is 69. And probably S, right? 42. They better have given us one side. What side did they give us? Oh, PQ. PQ is 71. Okay. So we're going to do, so you know we have to find this middle side. So I'm going to do a different color. Let's go with red. Oh, not red. Let's go with green. I want to find Y. So we're going to do Y over sine of 74 is equal to 71 over sine of 41. All right, we're just going to cross multiply. So y times the sine of, is that a 41? 41 is equal to 71 times the sine of 74. Divide by sine of 41. And I get y equals, and don't round this, 71 sine 74, 71 sine 74, oops, enter, divided by sine 41. Should have put that in as one fraction. All right, so I get 104.029, 104.029,633. Good enough for now, 633. Don't round it. So now we know y, and we're good. Now I'm going to put that y over the sine of 42. So 104.029633 over the sine of 42 is equal to, hopefully this is above my big head, is equal to x over the sine of 69. X over the sine of 69. So I get x times the sine of, what was this number? 42. Can't even read my own writing. 42 is equal to this 104.029633 times the sine of 69. Divide by the sine of 42. I know you got to keep track of all these big, long numbers. And so we'll end up eventually with x equals, so this, wait, hold on, control division, this times the sine of 69 all over sine of 42. 145.14, 3606, rounded, doesn't say, so I said rounded to the hundreds place, 145.14, there it is. And I think that was what number, that was 27, I got 2 left. Well, the more I do, the less you got to do. This one. Ooh, this isn't bad. A, B, C. Angle A is 30. A is 9. B is 18. So we're going to do 9 over the sine of 30 is equal to 18 over the sine of B. So 18 times the sine of 30 is equal to 9 times the sine of B. Now, if you typed 18 sine 30 into your well, divide by 9. So, by the way, sine of 30 is just a half. So 18 times a half is 9. 9 divided by 9 is 1. So you end up with sine of B is equal to 1. Well, that means B has to be 90 degrees. Well, if B is 90, so I would go 90, 30, that's 120. That leaves me 60 degrees. Well, the only other angle B could be would be 90, because 180 minus 90, it's still 90, so it's 90. There's only one angle, it's 90, it's a 30, this actually turns out to be a 30, 60, 90 right triangle. All right, the last one I'm going to do is this one. Find the distance JM. So let me get my red pen out. We're going to find the distance JM, this distance right here, X. Let's see. Angle JKM. JKM, that's this angle, is 41 degrees, 40 minutes. Let's see if they give us anything else. KL is 100. Ooh, so we know this. JLK, that's this angle, is 38:20. 38 degrees, 20 minutes. And we're going to find it to the nearest meter. So this is another one of those, find the side that they share. There's no way I'm going to find this X right away. There's just no way. I can use this triangle all I want. There's no way I'm going to do it unless I have the adjacent side or the hypotenuse. So we're going to find this one, this Y. So Y over sine of 38 degrees, 20 minutes is equal to 100 over the sine of this little angle right here. I don't know what that little angle is. Now, if you remember before, these two angles have to add up to 41 degrees, 40 minutes. So I'm going to take my calculator, 41 degrees, 40 minutes, and I'm going to subtract off, minus the 38 degrees, 20 minutes. It's going to be a tiny little angle, and I'm going to DMS this. So I get 3 degrees, 20 minutes. 3 degrees, 20 minutes. Now I could have done 180 minus 4140. I would have gotten like 140 something here. And then I would have taken this one and this one, subtract them from 180. I'd still end up with 3 degrees, 20 minutes. So now I'm ready to rock and roll. Let me grab a different color pen. We'll roll with the new purple pen. So y times the sine of 3 degrees, 20 minutes is equal to 100 times the sine of 38 degrees, 20 minutes. Divide by sine 3 degrees, 20 minutes. And no, the 20 minutes don't cancel. So, grab my calculator, and I go, okay, control division, 100 times the sine of 3820 all over the sine of 320. Oh my goodness. Oh my goodness. Tell me I don't need a new computer. 3. 3. All right, just need to hit the right buttons. 20. Enter. We found y to be 1066. 1066.77. 707. 707. 913. 913. Good enough for now. All right, that's y. So now I have y. So now I'm going to use the law of sines again. I'm going to do that over 90 is equal to what I'm looking for over the 4140. So I'm going to do this 1066.707913 over the sine of 90 is equal to y over the sine of 41 degrees, 40 minutes. Let me make sure that was right. 41 degrees, 40 minutes. So y, oh, this is x over. I should call it x. All right. Grab a different color pen. We'll use black. So x times the sine of 90, but the sine of 90 is just 1, so we don't need to worry about that anymore, equals 1066.707913 times the sine of 41 degrees, 40 minutes, and x equals. So really all I got to do is take this thing and multiply by the sine of 4140. 4140. 709143. 709.143. And there's our answer, but that doesn't look right. That's not what I got over here. Oh, I used the wrong angle over there. Oh, I know why. That's all right. There you go. We're done. It's over with, man. There's the answer. That's it. That's it for this day. I'm all finished. I'm out. Get me out of here. Spilled coffee on myself. Computer's not working. It's been a long morning. It's already 7 o'clock. We've been going for an hour. Oh, my gosh. Goodbye, kids. It's been fun. Bye. No, really, bye. No, go. No, just go. You go first. You go first, then I'll go. You go first, then I'll hit the stop button. Just go away. Go. Dude, seriously.